as one is phi is equal to function of psi, arbitrary function of psi. Okay, so x minus or to be or psi is equal to function phi. X minus z is equal to f of x minus y, or x is equal to, or 2 root z is equal to 2 root z is equal to x minus f of x minus y, or z is equal to 1/4 of x minus f of x minus y square. Okay, solution z is uxy is equal to this. From here is function, arbitrary function you take, arbitrary f we take, we consider, we cannot produce the trivial solution z is equal to 0. We cannot make this 0 for whatever. Okay, whatever f we take, we cannot produce, we cannot make it this right hand side as a 0. Okay, so there exists no f such that this z is equal to 0 is covered in the general solution. So what is the conclusion? Conclusion is general solution is general solution does not cover all solutions. Okay. So, but here in the beginning itself, you can see that when we are considering this, yeah, this is the methodology. Even we will write here 0 also, but from here we can clearly trivial solution z is equal to 0 is not covered in the general solution, and hence general solution the covers all okay. This is the conclusion of example for that. Now come to problem. This is a typical problem. So there can be many varieties of problems. So notice what is happening. Uy is equal to u square. This is an example of semi-linear PDE. That is, functions of xy, not u, not functions of u. So in that, what we call the characteristic curves, projected characteristic curves, they will be only on the xy plane, characteristic curves. So we first find the projected characteristic curves, describe all projected characteristic curves. So just solve dx upon right, dx upon y square is equal to dy upon x. Because we are bringing in the concept of characteristic curves, we can take, yeah, we can even write dx by dt. So yeah, to see the, yeah. you can write, even instead of writing like this, you can write dx upon dt is equal to y square, dy upon dt is equal to sine z square. Okay. So from these two equations, dy upon dx is equal to what is this? This is x upon y square. So this implies you can differentiate both. That is y square dy dx is equal to x. This implies integrate y cube upon 3 is equal to x square upon 2 plus a constant c1. Constant c. These are the, so these are right. You can also write x square by 2 minus y cube by 3 is equal to c. These are curves because they are why they are called projected, because the characteristic curves are in the, they are only the curves in the xy plane. Now second part, b part. What is b part? Determine the values of ux, uy, uxx, uxy, uyy on the x-axis. On the x-axis, when we are given the, take the same equation with initial condition u x comma 0 is equal to x. Okay. So without solving for u, for u, finding u is two derivatives. Action problem, please wait. So am I audible? Am I audible?
Yes, sir.
Okay. So so what is we are asked, we are not solving this problem because solving sometimes is very complicated. So what we need is some of the derivatives of the solution on some x-axis or y-axis. So here we are asked to find ux, uy, uxx, uyy, uxy, etc. on the x-axis. So how to go about it? So first thing is given is on the x-axis y is equal to 0, that is u is given to be on x-axis. The first thing. Second thing, what delta x goes to yeah, is it delta? Yeah, minus u delta x. This is the definition of u. So this is equal to limit delta x goes to 0. What is u of x plus, that is u of x plus delta x? sorry. It's, delta x comma 0. Goes x delta x comma 0. Yes, u x comma 0 upon delta. Yeah. So if you are not able to see or hear my voice, you please let me know. Okay. There is some network issue. So what is u of x plus delta x comma 0 that is given to x? So this is x plus delta x minus this is x upon delta x. This goes to, so this cancels out and this cancels out, this goes to 1. So so we may this is ux, u is equal to x. So we may think that then directly ux is equal to 1. Don't write like that. We have to write by the formula because this value, this u is equal to x. Xy different to find how to find uy 0, uy x 0. Now go to the equation. And PD is this one. Maybe we can get directly from this PD y square ux plus x uy is equal to u square. Okay. Now put y is equal to 0 here because already we have put y is equal to 0 in the equation. So this goes to 0. U y x comma 0 is sine u square. Y x comma 0 is sine u square upon x. Okay, so if you find that sine ux uy value, is it correct? That is correct. So now this is this thing. Now what is now next is second derivative uxx uxy or uyx and uyy. Second derivative. How to find second derivative? So again uxx x comma 0 is equal to, by again go by the first principle, delta x goes to 0, ux x plus delta x comma 0 minus ux x comma 0 upon delta x. This is equal to, what is ux x comma 0? We have found out that we have found that ux at x comma 0 is 1. Okay. 1 minus 1 upon delta x is 0. So ux is at x comma 0 is equal to 0. Next, now next is u at x comma 0. First, for differentiate the given equation with respect to y. So we have y square ux plus x u sine u with respect to y, both sides. So 2y uxy plus x times uyy is equal to sine derivative is cosine u square 2u into uy. Okay. Now put y is equal to 0. So this goes to 0. X uyy x comma 0 is equal to cosine u square. What is u? U is x. So 2 twice. And what is uy? Sine square upon. So this x get cancelled. Finally, for that differentiate with respect to x. So what we get? Y square uxx plus x times uyx plus uy times 1 is equal to cosine u square 2u ux. Put 0, this goes to 0. X times uyx at x comma 0 plus uy is something like sine y square, this thing is equal to cosine where 2 times u is x and ux is 1. Okay. So this is the final answer. From here you write this. So this is a typical problem to find, extract the derivatives one by one without even solving the given PDE.
Sir,
Yeah.
ux in this question, uxy will be equal to uyx.
Yes, correct. Because you can verify also. Even you can find that will be also the same thing. Yeah, the mixed derivatives are equal provided the solution is smooth. We don't know about anything about the solution whether it is smooth or not, but here it will turn out the same. Mixed derivatives are equal. Next we'll go to problem sheet 2. So this is the problem sheet 2 is on weak solutions. That is shock rarefaction or expansion facts. Okay. So problem 1. Solve the initial value problem AU uy is equal to 0 with initial condition hx. Same thing, dx dt is equal to, by method of characteristic, you have this is equal to a of u, dy upon dt is equal to 1. Is 0, that constant will be equal to hx. So this will give us y is equal to t, and this you can differentiate. This is xst is equal to, because u is constant, that is z. This is a of z. That is constant a of t, and that constant put t is equal to 0. That is equal to a h of s t plus s. Now finally is equal to h. What is s? S from here is sorry, x minus a of u times y. Okay. This is the final solution. Final solution is this one. So now what show that the solution becomes singular for some y positive, unless this is non-decreasing function. What we are asked here to show is that so that this is non-decreasing. How this is proved? Now singularity. How to check the singularity? This is the. Now just do the differentiation with respect to x. This one. This is into differentiation with respect to x. So this is 1 minus a prime u times ux times y. Okay. So from here, if you bring this, this ux h prime upon plus a of hs, and what is ux? Sorry, ux is gone, so this is h prime. Yeah, this close, and this is multiplied with this h prime s into y. Okay, so now analyze here. This denominator becomes 0. A prime is negative. This becomes the possibility of this becoming 0 is when a prime is positive, no problem. H is h, yeah, h also, h prime s, and this is negative. So and so given that y is positive, this y is positive, so we can eliminate this only when these becomes 0. That is what that implies. This is if this is negative and this is negative, then there's no case though. So one of them is negative. That is the case, and that implies that a of hs is decreasing function of s. Derivative negative means what? Decreasing function of s. Hs is a decreasing. So unless this is a decreasing function, we will not have problem. There is no singularity. So whenever this is becomes a decreasing function, then we will have a problem of this denominator will have the problem in the singularity. So that is the analysis. Now let us go to problem
Sir,
2. Yeah.
sir, what is the meaning of singularity in this question?
Singularity means what? The solution is not smooth, is not differentiable. Okay, that means what? Derivative does not exist because this is a function. We have ux and uy. Derivative does not exist. Okay. So first we are checking with this one. If this itself is that's what one of them fails, then it is gone. So first we are checking with this one. When this does not exist, when this is becoming a decreasing function of s. Fine. So now go to problem 2. From here, these are all like typical problems. Problem 2 is the case which ux is equal to 0 with initial condition x is equal to hx is equal to. I think we have solved the case when u naught is 1 and 0. Is this the case? Hx is when x is negative, less than or equal to 0, between 0 and greater than. And the initial profile is continuous function. Continuous function case we have solved. So here we are asked to do with general u naught. Instead of this one, we are asked to put some positive quantity u naught. Just repeat here. So even the solution initial profile is continuous function, but the discontinuity crops in. Discontinuity will come into picture. So that's what it is asked to show. So that the shock develops at a finite time and describe weak solution. Here the shock developed. There was no problem for t is equal to 1. T is equal to 1 for this the characteristics were positive. So the characteristics were this is 0 characteristics. X is equal to s character. Then we have these characteristics and we have these characteristics. So here there is no intersection of character intersection of characteristic line. After t is equal time t is equal to 1, after finite got into problem of here the intersection is happening. So there we have defined a new problem and found the shock propagation curve and defined the trade-off. How left take u is equal to 1 and right side take is equal to 0. That's what we have done. So here also it will now come to problem with initial initial condition. Yeah. What is the initial ux comma 0 is equal to hx is 0 when x is and when x is positive it is u naught into x minus 1. When x is positive, where u naught is a. So how to draw the that is x is negative, it is 0. Okay. Suddenly there is a at x is equal to, and from there it minus 1 and then again yeah there is a jump here. X is equal to 1, it is becoming 0, and x is equal to 2, it is becoming some u not positive again. Sorry. This is when x is equal to 0, it is minus 1. Minus 1, it will go like this. So hx is 0, jump. So this is our hx. Okay, this is minus 1. So what is the profile here? Here that is something 0 and negative. This thing. Draw the characteristic. Where is 0? We have these characteristic lines. Okay. When they are in between 0 and 1, what is how the characteristic line varies, and after 1 line varies. So what is 1? It is given here. So we have to find substitute and find the characteristics, and actually this in notes. So kindly go. We can discuss it in the next class. Okay. Now let us go to problem 3 again. Problem 4. 4 is because UL left right hand velocity. So what will happen? UL is less than UR. So we'll have something. Find the continuous solution. So whenever is UL is less, there is no. These will be lines like this, and these will be lines like this. Characteristic lines will be towards left hand side. It will be like this towards right hand side. Okay. Whenever this is like if this is positive, this is and this is positive. Okay. If both are negative, also there is no problem. Both are positive. What is the situation? One is positive, one is negative. Then if both are positive, also there will not be. So some slope difference will be there. This is lesser slope. So this will be slope like maybe yeah, something like these lines, and from here it will be something like this. So still there is a vector. Okay. So these are called expansion fans. In this fan type region, you have defined a continuous solution, and that we have use five. So this expansion fan case, you use problem 5 to define the solution uxy is equal to v of x upon y. Simple wave solution, or in our case, Burgers equation case, this will be just x by y. So in the region where there is no intersection of the characteristics, define u is equal to x upon y. So with this, we completed problem sheet 3. Now coming to problem sheet 3. See, these are problem sheet 3 is based on entirely on non-linear PDEs. That is fully non-linear. That is function of x, y, u, ux, uy is equal to 0. Okay. This we are calling it as P. This we are calling it as Q. So now this has become a function of 5 variables: 1, 2, 3, 4, 5 variables, like x, and this is equal to z, x, y, z, p, and q. So 5 variables. So we need 5 equations, 5 characteristic equations, and dq upon dt. So how to get these 5 characteristic equations? And the initial gamma is Fs, Gs, Hs, phi s, and psi s. So if you are given an initial condition ux comma is equal to hs, fs is this, gs is this, hs is this. But what is phi s and psi s? So we need to develop a theory where which will give us the things, and also characteristic equations, and using these 5 equations with these 5 data 1, 2, 3 up to this thing, we will develop we will see the theory first and then go to the problem sheet 3. So in the next class we will try to complete the quickly have a look at the problems. Okay. So one extra thing comes here. We not only have general solution, integral surface, but we also have something called complete integral. Okay. In the general nonlinear case. Okay, completed. So we'll stop here and we'll meet on Friday. Whatever we complete on Friday and the problem sheet 3 also will complete. We will have exam on Monday. If you have any doubts, we can have an extra class Saturday 10 to 11. If you need an extra class, doubts clearing class, we will meet on Saturday 10 to 11. Monday is exam. Is that fine? We'll stop here.
On Friday, you will discuss theory or you will discuss Q3?
Theory is not much. It will take only little time. I will finish the theory first and then solve the problems. There is nothing to by heart or anything here. We have to know what is happening, why these how these 5 equations are coming. We don't have to mug up anything. Now everything is open book exam. So have an idea what is happening in this, how the equations have come, and immediately solve the problem so that you will understand more. I think we can finish. We can finish on Friday. A little extra time we will take and finish the entire thing. Okay, fine. Shall we close here?